so we will wrap up the, if you want to call it the lecture material for this. Just have a little bit left to go over. Then we'll get you on your way. And then tomorrow we'll start talking about the organic reactions that accompany this this chapter or this segment of the material that we are have been discussing for a little over a week now. Okay, so with this, what can you see in the blue writing? Do you suppose that is a molecular formula, or is that a structural formula of a hydrocarbon behind it? Does it show you the formula or the structure? It shows you the structure, so therefore it's going to be one of these structural formulas. Now these there's a slight difference between them, and I'll show you what that is here in just a moment. Because to me, in my mind, the author chooses to use these two terms, and a molecular formula to me is very much like the condensed structural formula, because it says types that not show only the carbons and hydrogens, not the bonding between them. Okay, so I'll show you what that means here in just a moment. But for our practical purposes up to this point, we've been using just nothing but the structural formula, the expanded type, which to me, I think is more beneficial for you individuals. But when you look in the book, just notice that they're showing the molecular formula instead of the structural type. Okay? So a ring structure, and we're talking about cyclobutane, why would we say, why is that a box? Why does that illustrate a box? Do you think? Any ideas? Yeah, because there's 4 carbons to it. That's right. Okay? That is correct. So, one of the things you'll notice, you probably get better at your drawing skills, if you want to call it, if you have any. Maybe you think you don't have any drawing skills. That's one of the things that I think people maybe like to make a little lighthearted conversation is I didn't know how good I was drawing until I took organic chemistry. Yeah, and that's something to maybe look forward to. Okay, we got this one, and then this, and then I'm willing to bet that is it. Okay. Kind of a distraction sitting in here, or there's excitement, or just ready to go. Let the Bulldogs have it. Do our best to do that. Now, whether that happens, of course, no one really knows, because we don't go by what's on pencil and paper or speculation. You just got to wait till we, of course, get there. Okay. So I think there's only one slide left, right? Or I mean to say correct. I hate saying left and right at the same time. Okay. One slide left, correct. Okay. So with that, then we can get you on your merry way. One of the things we'll possibly hand out next week is part of your vocabulary, and parts of this would be how you actually communicate these types of concepts. What is a molecular formula, structural formula, a branched chain? What is the parent chain? What is an isomer? What is an alkane, an alkene, an alkyne? And a lot of times, I think it's maybe just hard to visualize. You're using it every day, you just don't realize that you're using it. Just like if you are in the, we'll just say in the back row, you don't think to see what's happening. You react to where the ball is going. Okay? And I think that's a pretty fair assessment. You just don't really realize that you're not thinking about it. You're just using your volleyball skills. You don't have to think about it. You're using this content all the time. You're using this specific type of vocabulary. You just don't realize you are using it. Okay, does everyone have this information that wants it? Alrighty. Okay, so one of the things we've been looking at these derivatives on page 308, and if we're talking about a propyl group, okay, how many different types of propyl groups are there? Or is there only one? Or is there two? Or is there three? That is correct. There are two. Okay? You have just a regular propyl group and isopropyl group. Okay? How many ethyl derivatives are there? Just one, two? Probably not three. So it's either one or two. Only one. How many different types of methyl derivatives are there? Yeah, there's only. Why can there only be one? You are really close. How many carbons are in a methyl group? One. So there can only be one type. All right. So moving forward, we have not seen the butyl derivatives, and you can see those on page 308. It's the bottom four. Okay, so you have a regular butyl group. The S is for secondary butyl group. You have isobutyl and tertiary butyl. That's what the S and the T are standing for. Now, according to the rules, do we disregard the S and the T for those butyl groups, or do we use those in alphabetizing? We just read it once, and that's perhaps maybe why we might not know that right away. Because if we had a methyl group and a propyl group, which one would we put first in the name, methyl or propyl? It would be methyl. Why is that? Alphabetizing. That's correct. Now, if we had a propyl group and an isopropyl group, which one would come first? It is the isopropyl group. We disregard prefixes when it comes to that of isopropyl. So therefore, secondary butyl or an ethyl group, which one would come first? Right idea, but the S in secondary is a prefix, okay? And it's hard to remember all this, okay? Now, this is why. We're not trying to make this up. We're not trying to set this trap, or we're not trying to say, oh, yes, I got him this time. No, that's not what we're trying to accomplish here. Okay, so in 2C, it says alphabetize the names of alkyl groups when there are two or more different types of groups. Ignore all prefixes, both the branching prefixes S and T, and multiplying prefixes such as di, tri, and tetra in alphabetizing, with one exception. Iso is not ignored in alphabetizing. Okay, so the I you would use just like you do the M in methyl, the E in ethyl. You disregard the Di in dimethyl, the Di in dimethyl, or the S in secondary butyl, or the T in tertiary butyl. Okay, those prefixes, you ignore those. Then you go by the second term. Okay, all right. Confused? Well, hopefully, when we put this to practical use, we'll get everyone on the straight and narrow, straightened out. Okay, you're just teeming with excitement. I know. I can tell. Awesome. All right. Yep, my microphone's still working. All right, so I'll give you a couple minutes or whatever it takes to get these wrote down. Okay. And again, I'm not going to walk around to see if you have it wrote down. It's a choice whether you want to write it down or not. That fan is a good idea. I bet that just plugs right into your computer. Are we ready to proceed? Okay. I don't know if you can tell. Got a black color here, a purple color here, and a blue color over there. So, black, blue, or purple, or does it not matter? Okay. So, the first thing that we want you to do in any one of these compounds is what? Find something particular. The longest chain, that is your parent chain then. Okay? So in this case, your parent chain is what? Okay, I think it is octane. Right? Now, it wouldn't matter if you counted this way, or it went up and over. Okay? You might say, well, this is a branch. Well, it could go this way, and that's a branch as well. Because regardless, there's a methyl group branching off of carbon, whether you're going up and over or straight, and that one's down. So like you correctly said, octane, 2, 4, 6, and 8. So remember, X marks the spot. We'll say where these are at. We got derivatives on those two. Now, we've got our octane. And there's always going to take a lot of space to write these in. Okay? We need to account for these derivatives that are branching off of here. All right? So in this case, we need to identify what those derivatives are. What is this derivative here? It's only one carbon in length, so therefore it is a methyl group. And there's nothing wrong with doing something like that. So otherwise, if you're working on these and you get distracted, and then you come back to this, you can see, oh, I got an M there. That must be a methyl group, which is true. This derivative, however, is what? And it's on page 308 if you think you need a quick refresher, because it has that structure on there. And we did write it down yesterday, so perhaps it's in what you did yesterday. A clue would be how many carbons are in this derivative. Okay? So that means one of the first questions that we had to ask, how many different types of derivatives are in a propyl group? Yes, that is an isopropyl group. So therefore, what we see happening, you can just put I and P up here for isopropyl. All right? Is the I a prefix, or is that part of the actual derivative? It's part of it. So do we use the I in alphabetizing? Yes. Yes, we do. Okay. So now we've got our octane. We've got these two derivatives. Okay? So we need to figure out the lowest combination that would give us for numbers, or think of golf is what we would say. So I think just by even glancing up there, you know you're going to go left to right, because if you go back this way, it's, 5 and 7. So you wouldn't want to do that. If you go this way, it's on 5 and 7. But if we go this way, it's on 2 and 4. So therefore, now we've got our numbers, but which one of these comes first? Do we put the isopropyl group first or the methyl group? You are right, but why are you right? Right, even though this has a bigger number, you still put the alphabetized one first. So in this case, it's 4. So you would put 4. And how do we separate numbers from words? Okay. Isopropyl. Oops, them two switched around. Okay. Dash, or other derivative is on which carbon? This one, which would be a methyl group on which one, though? On the second one. He said sometimes when you're writing these out, you think you have enough room, but you run out really, really quick. All right. Okay, so a little bit of a review on this one. The purple and the blue are new. So which one? All right. Again, everything you want to approach the same way. Find the longest continuous chain, which if I was counting right when we wrote it, I think it's 9, correct? Okay. So what is the name of an alkane with 9 carbons? Okay. So a quick review. Since this ends in ANE, what is that telling you? That every carbon is what when it ends in this suffix? It's all single bonded. It's saturated. That's telling you how many carbons are in your parent chain. So now, again, X marks the spot. I think it's almost right in the middle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? So it doesn't matter which way you're going. Okay? This way or this way. But what is a little different, or might be, is this guy right here. The first thing you'd want to look at, how many carbons are in that derivative? There are 4, so that means it has to be what type? It has to be one of the butyl groups. And again, those are found on page 308. Okay? And with that, what you can do, and maybe you want to make a little side note for this. Having a competition, see who can make the most noise. Who's winning? Don't you wish you were out there? Oh, okay. Don't you wish you were in here? All right. All right. Okay, so what I'm going to do here, this X is standing for any one of these carbons where it attaches the parent chain. So, just like what you would see on page 308, okay? So this X is attaching to the parent chain. Again, how many carbons are in this derivative? 4. And which of those 4 carbons attaches to the parent chain? The second one. Therefore, this is called secondary butyl. Okay? It's because it's attaching to the second carbon. Another one, X is the carbon. It's the variable here. Okay, it's still a 4-carbon derivative, but this is a tertiary group because this carbon has 3 of them around it. Okay, so therefore this is tertiary butyl. And then the last one we see is this one, and that is what we call isobutyl. Again, it's got 4 carbons in the derivative. It's how they attach to the parent chain that keeps them separate. So again, this one is isobutyl. So in alphabetizing these, okay, the only one we don't have up there is just a regular butyl group. I'm not going to put that on there. We'll cross that bridge at another time. But alphabetizing those three derivatives we just put up there with the X's on, which one would come first if you needed to place them on a parent chain? Isobutyl comes first because of this. Are we sure? Are we positive? Okay. This is what makes it so tricky. Okay. Alphabetize the names of the alkyl groups when there are more than one groups. Okay. Ignore all prefixes, both the branches, prefixes secondary and tertiary, and multiplying prefixes as ditri and alphabetizing. With one exception, iso is not ignored. Okay, so in this case, you're looking at, you go by the B, because you are ignoring those prefixes. You do not ignore this one. Okay. A little bit tricky. There's always exceptions to the rule. We confused? Awesome. Okay. So with that being said, so now we've got our nonane here, and you said this is a butyl group, but which one is it? It's an isobutyl group on the 5th carbon, so this would just be 5-isobutyl nonane. Okay? And then finally, what do we have up here in the blue? I think that's still a nonane. Well, it's only 8. 2, 4, 6, 8. Okay. So it is octane then. Okay. And then what type of derivative do we have branching off of there? It's a butyl group because there are 4 carbons in there. But the one that starts with a T, it is a tertiary or T butyl group. Okay, so if you want to put a dash after them, you can. It's really not, in my estimation, we're not going to beat you up over anything. If you want to put a dash in there, fine. If not, that's fine too. Now, for those of you who take this in a year or two or to whatever effect, you may need to be making adjustments to what you are responsible for in college. Okay? We're skimming across the top. We're trying to give you a nice wide base foundation that should you be in a class that you are seeing this content again, that we are successful in it. That is our goal. Now, are we going to accomplish that goal? I don't know. Only you can answer that when you arrive to that point in time. I think the worst thing we could do is, oh, well, that's just too hard. We're just not going to do it. And then all of a sudden you get faced with this in college, you might get clobbered, and we don't want that. And I think you would agree that is the best course of action for us to do, is give us this nice wide base foundation so we can be successful. All right. So, right side, are we good? Left side, are we good? Middle, are we good? All right. So I'll get you your paper, and which I see I have it due on Tuesday, so it's not a whole lot. If we're keeping up with this and you have good things to look back and refresh yourself with materials, we hope you're going to be just fine. So we'll catch up to you next time.